Hello viewers, today we're going to look at lesson number 7, which is number basis, under the subtopic changing basis of numbers. Right, I'm going to first give an introduction to what a base is. Right, so a base is like a signature, or it's like a base certificate. Everyone has a base certificate, so we're saying each number is what you call a base or its base certificate. So whenever we have our number n, let's say we have our number n, there's something that is here which is in lowercase b, which we are calling a base. So this is an identity of a number, right? So when you're dealing with number bases, we're saying you might have a number, for example, the number that you are used to, for example, numbers that we add in everyday life, like how many cars do you have? I have 2 cars, right? How many kettles do you have? I have 3 kettles, something like that. So those numbers are naturally in base 10, or so you're saying it's in base 10. Usually we don't indicate a number when it's in base 10, right? So that is why you can't actually notice it, since we were studying them from grade 1, right, or even from ECD. So we are saying when a number is in base 10, it's actually in the binary system. So we have been dealing with numbers in binary system all along. So today we want to introduce other bases like base 2, base 3, base 4, base 5, and so on. Right. So then another thing, whenever we are presenting numbers in a certain base, right, whenever we're presenting a number in a certain base, there is no individual number that is bigger than the base. So what am I saying? I am saying that, let's say I am given 2, 1, 2, that is bigger or equal. Yes, let's add equal there. Why? So let's say I have 2, 1, 2 in base 3. So my base is 3, so which means if I look at 2, I look at 1 individually, and 3, I'm not supposed to have a number that is either equal to 3 or more than 3. So everything that I'm going to write here is actually below 3, right? So the first thing that we are going to do is to change number from the system that we are used to, that is the binary system, the base 10 system, to any base that you are given. So I'm going to show you how you're supposed to change any number from base 10 to any given base. So this is how you're going to do it, right? So whenever you're given a number in base 10, for this example number 19, we want to change it to base 5, right? So this is what you do. You write that 8 like this, right? So then you draw a table, right? So what base do I want to change to? I want to change to base 5, right? So what am I going to write here? Here I'm going to write a reminder, right? So we're going to do a lot of division here, right? So I'm not saying 5 into 38, 5 into 38, 5 goes 7 times into 38, remainder 2. Then 5 goes into 7 1 time, remainder 2. Then 5 goes into 1, 0 times, remainder 1. It's remember, 1 is less than 5, so we are going to write 1 is that remainder. Now, so you actually do this method, or you repeat this method until you have reached a 0 here. Now the most important thing is, or are these reminders, right? So now when you want to write your solution, you write it from the bottom where you finish up to the top. So we are now saying 38 in base 10 is the same as 1, 2, 2 base 5. So again, Another important thing here is 38 in base 10 can be written as 38. So whenever a number is in base 10, you can actually put nothing here. It actually represents that the number is in base 10. So please don't forget to put a base on your solution whenever it's not 10. But actually, let's say I've forgotten my 5 there. This number is actually in base 10, right? So please don't forget to put the required base whenever the number is not in base 10, right? Now let's look at example number 20, which says convert 23 to base 2, right? Let's write our table. You're going to write the base that we want to change to, then you're going to write the number that we want to change, right? And here you're going to write reminders, right? So we want to convert the 23 to base 2, right? Now let's do division. 2 into 23 goes 11 times. Remainder what? Remainder 1. So 2 again, since you've not reached 0 yet, you have to continue. 2 into 11 is 5 times remainder 1. 2 into 5 is actually 2 times remainder 1. 2 into 2 is 1, remainder nothing. Then 2 into 1 is 0, remainder 1. So now we have reached 0, which means we have reached our ending point. Now we have to write it starting from the bottom going to the top. So we are saying 23 base 10 is the same as 1 0 1 1 1 base 2. So remember, like this question, they haven't indicated the base, so it means the answer is, or the question is in base 10. Please, you have to remember that idea. Now let's look at example number 21. We're actually now going to change from base n to base 10. Right, so please take note of this idea that I'm going to illustrate here. When you're changing a number from a certain base, right, you actually have to be good in powers, right? So for example, here I'm given 11 base 2, right? So this is what I'm going to do. You write each number individually, right? You multiply it by the base. So I have 1 times the base. You add, I have this 1 times the base, right? Now on the base, I have to indicate powers. Starting from my right side going to the left side, I have to start from 0 to 1 until the number of bases is depleted, right? So this is how you write your powers. This is the simplest method of writing powers without even thinking what you're doing, right? Then you simplify mathematically, right? So simplify here, simplify here, then you add. So which means 2 to the power 1 is 2. Then 2 times 1 is a 2, plus 2 to the power 0. Remember, any number raised to the power 0 is 1. So 2 to the power 0 that's 1. 1 times 1 that's 1. So I'm going to get a 3. So we are saying 11 base 2 is the same as 3 in base 10. So please, when you're dealing with numbers in base 10, powers are only placed on bases, and don't forget to put your powers. Now let's look at example number 22, which says convert 631 base 7 to base 10. Right, now when I'm changing a number from base n to base 10, what I have to do is to write each number being multiplied by the base. Then I add it to the next number, so it's 6 times base, 3 times my base there, plus 1 times my base, right? So the next thing is to write powers on the bases. Please take note, only on the bases. Why? Starting from my right hand side going to the left hand side, I start from 0 1 2, so I indicate those bases until the bases. I've depleted the bases. Wait. So then I simplify them. So now I'm going to get 7 power 2 is 42. 6 times 42 here. Everything that I'm going to get there. 7 power 1. A number is power 1. It remains the same. So it's going to be 7. So it's now 3 times 7 plus 7 power 0. A number is power 0. That's a 1. Right. So 6 times 42 is going to be 252. Then I'm going to add 3 times 7, that's a 21 there, plus a 1. Right. Then I add now 1 plus 1 plus 2, that's a 3. 2 plus 5, that's a 7. Then 2. Then my answer is 273. Wait, on the question section, there are questions which says convert something like from base n1 to base n2. Wait, these are different bases. They're now saying don't change, or they're not illustrating for you to change to base 10. So whenever you want to change any number from any base to another base which is not 10, this is how we do it. First, you change your number to base 10, then you go from base 10 to base 2. This is the route that you only take. We actually don't have a method in A level that actually solves problem from base n1 to base n2, right? We only have methods that are used to change from base n1 to base 10, then base 10 to n1. So please don't forget that. Let's say, for example, when I have to change from base 8 to base 10 to base 2, sorry, right, which means I have to pass through base 10, then I go on to base 2. So now do the following questions by yourself. Thank you.